For this next video, we're going to look at the next point in the exploration section. Exploration point 2, the background information you provide for the investigation should be entirely appropriate and relevant and enhances the understanding the context of the investigation. So let's look at the exemplar. So this is the background section. This is where you explain the physics behind what you're going to do, and any equations that you're going to use, you should be deriving them here. So this is where you describe what's going on, and you quote any formulas that you're not going to derive with a reference. And now we're going to derive the formula that we are going to need. So if we keep the compression constant and vary the mass of the cart and measure the speed, we're going to measure the time taken for the cart to pass through the light gate. So we can calculate that from the equations that we've already got. And then what we can have a look at is, so this is the final equation. We're going to change the mass on the cart and measure the time taken to go through the light gates. And this will give us access to the spring constant of the car. So I've just written here that the time squared is proportional to the mass. And what we're now going to show is what it is we're going to plot as a result of that. So this is in the form y equals m, where m is the gradient, x plus c. So this means we're going to be plotting the time squared on the y-axis, the mass on the cart on the x-axis, and we expect the gradient to be d squared over kx squared, where d and x we've defined over here. D is the length of the cart, x is the compression of the spring, we've said somewhere earlier up. X is the compression of the spring, and K is the spring constant that we're trying to find. So I've got Y, which is the thing I'm plotting on the y-axis, equals M, the gradient, which is some constant, times the thing I'm plotting on the x-axis, plus 0. My pen has stopped working. There we go. Plus 0. I can always write and add 0 at the on an equation, and so we're expecting a straight line through the origin with a gradient of this and an intercept of 0. So that's what I draw. I draw a straight line through the origin with t squared on the y-axis and m on the x-axis with a gradient of d squared over kx squared and an intercept of 0. So this is what we expect. This is our hypothesis. This will then, if we plot this graph, calculate the gradient. That will allow us to calculate the spring constant, which is a thing that we said we were going to measure in the research question. Do we need anything else here? No. This is that second point in the exploration section here, the background information. So what we've done is we've not waffled about anything that's not relevant, and what we've done is we've derived the formula we're going to use. I've specified all of the variables. I've said what it is I'm going to measure, and on what graph I'm going to plot, and therefore what I can read off of that and how I relate it to the research question.